Alrighty. Okay, so let's get a hard one today. Kth smallest product of two sorted arrays. Given two sorted zero index integer arrays, nums1 and nums2, as well as an integer k, return the kth one base smallest product of nums1 I times nums2j, where 0 or I is some index in the nums1 array and j is some index in the nums2 array. Okay, so given two sorted arrays, you want to find the kth smallest product from any combination of some number from nums1, and some number from nums2. Pretty straightforward in terms of what that means, even if it's probably difficult in terms of how to find it. Example here is you're trying to find the second smallest from these two arrays. The smallest is obviously 2 times 3, which is 6, and then second smallest is 2 times 4, which is 8, which is going to be better than 3 times 5, which is 15, or 5 times 4, which is 20. Obviously, 6, 8, 15, and 20 are the only combinations possible, products that are possible from multiplying. And the numbers could be negative. In this case, let's try 6 smallest, it ends up being 0. And some combinations could be, I guess, are the nums. The numbers can have duplicates, I believe. They definitely can't have duplicate products, but I think they can have duplicates within the array itself. There's no restrictions here. Okay, so I was thinking of this probably like 30 minutes, 20 minutes. So if I were to think about a table where the rows and column headers are the values of the arrays themselves, the table will, and this is a multiplication table, product table. So let's say I extend out 2, 5 with an 8 and 3, 4 with the 15, ends up being, these are the products. And if you were to traverse or order the product that results from any combination of values from those numbers, from those arrays, you get something like this. And if I were to think about it in terms of indices, let's say the row index and the column index, the order that you will go through for these values would be 6 to 8. So this is index 0, 0, index 1, 0, row 1, column 0. And then 8 goes to 15, which is row 0, column 1. And then 15 goes to 16, which is row 0, column 2. 16 goes to 20, row 1, column 1. 20 goes to 32, 20 goes to 30, row 2, column 0. 30 goes to 32, row 1, column 2. And then 2, 1. Anyways, so this is the order of rows and columns as it traverses. And obviously, like 6 and 120 are going to be the lowest and highest possible products. And so 0, 0, and kind of the n or n-1, n-1 is going to be the start and end of this ordering. And then somehow you're traversing through each element. But at any given time, you are generally moving, if I kind of imagine like a boundary here, like 6 is kind of the boundary, the starting boundary, and then 8 and 15 become the starting boundary after you remove 6. And then from 8 and 15, the boundary can either be 30, 20, or 16. So the boundary kind of changes, kind of updates. So because I remove 8, the boundary becomes 30, 15, so 6. The boundary is 8 and 15. Once I remove 8, the boundary is is the boundary 30, 15? No. Oof. 8 is removed. 8 could move to 20 or 30. I think the boundary after I move 8 is actually 15, 20, 30. And then after I remove 15, the boundary is 16, 20, 30. And then after I move 16, the boundary is 32, 20, 32, 30. Like right now, 15 and 20 being in part of the same boundary is kind of weird. If I remove 8, is the boundary just 15, 30? Why is there 20 in the boundary? So if I remove 8, it's just 15, 30. And then if I remove 15, 20 comes back into play. 16, 20, 30. I don't even know if this is an idea worth pursuing. Because I know that 15 is going to be always smaller than 20, given that you're dealing with the same row or same column in a lower row. But it also feels like at any given time, it can't just be 2. Maybe it's 2 at the starting, like 2 possibilities to compare at the starting. So when you move something, you add the possibility that it bumps up in the next row, or keeps the same row, bumps up in the next column, or keeps the same column and bumps up in the next row. No, sorry. Keeps the same column, bumps up to the next row, or keeps the same row and bumps up to the next column, except if the next column has, a the next column is already in consideration. Because if the next column is already in consideration, then you would stick whatever is being considered in that column. So 6 goes to 8. 6 goes to 8. 15. 6 goes to 8, 15. Is it possible that 6 goes to a previous row as well? I guess it's possible. So you can't just stick in the same column and go to the next row, because No, you should always be able to stick in the same column to the next row. But if you should be always able to do that, then you should always be able to stick in the same row and go to the next column. No, you should always consider the next row same column. The boundary, the boundary, the boundary. Eight goes to 15, 20, or 30. But shouldn't I be able to remove the 20? I think maybe... Is my example just off? What if I just flip the axes? 3. This is definitely showing the limits of my abilities to imagine. So this is 6, 12, 30. Oh, what's 6, 12, 6, 8, 30, 15, 20, 75, 24, no, it's 32, no, 24. Oh my god, I'm so stupid. What is going on with me? Just changing my thing. 6, 8, 6, 8, 15, 20. There should be 1, 1. And then it should be 1. It should be 0, 2. Row 0, column 2. 20 to 24 to 30. 24 to 30 is going to be 2, 0. And then 32, 1, 2, 2, 1, 2, 2. Okay, so. Alright, so 6 to 8 to 15. 15 goes to 20. So the boundary here is either 8 and 15. Once I do the 8, the boundary is either 30, 20, or 15. Once I do the 15, the boundary is 24, 20, 30. And then that goes to, once I do the 20, it becomes 24, 32, 30, and 75. That's such a big boundary. The boundary can't be two things. It should be, the boundary can't just be two things. Unless there has to be some combination of some example out there that the boundary is more than two things. So but then the boundary being like m plus n also seems a little too large. Where m and n are the dimensions of the table, of the size of the array. I mean, that's not terrible. It's not terrible. So you have to kind of have a heap and sort the smallest of the boundary each time. Or it feels like the boundary should be maybe the size of n or the size of m. So like so couldn't I say the boundary is like 24, 32, and 30, ignoring the 75, because I know that 75 is smaller than or bigger than 30. But then don't I know that 24 is smaller than 32, so the boundary is just 24 and 30? Hmm. 6 to 8. Boundary is 15 and 30. At that point, I should be, oh, sorry, in the 6, the boundary is 8 and 15. Take the 8, the boundary is 30 and 15. 30 because I could be bumping up this thing, and 15 because if I use 8, 20 is going to be bigger than 15. So 30 and 15. And then if I use 15, the boundary is what? It's 30, 20, and 24. Like some values there have to be considered. So that should be n right there. So maybe it's at most n is how many I consider. And then the lowest there is 20. And at that point the boundary is just 30 and 24. Because 20 goes to 75, which is strictly larger than 30 in terms of being on the same row in the higher column. And 20 also goes to 32, and 32 is strictly worse than 24 because it's the same column and a lower row. Or 24 is not a lower row than 32. So it's at most n, where n is kind of like a diagonal that doesn't share the same row and column with another element of the boundary. But the boundary could be at least 2, unless it's the last one where the boundary is just one more. Or maybe the last few, if you have just, so the boundary could be like 1. That's at most n values. How do you tell? How do you set that up? So if you go from a row and column, obviously the adjacent ones would be same row, higher column, same row, higher column, same column, higher row, but only if what? 6 goes to 8, 8 goes to 15, 6 goes to 8 and 15, 8 goes to 20 and 30. But if the next column that you're in is working on a lower row, then don't do that. Don't add that element. Or if the next row that you're in is working on a lower column, then don't do that. So you're keeping track of maybe 2 arrays of what the lowest column for any row that you're working on, and the lowest row for any column that you're working on. Okay, all right. Also, I think this does seem to iterate over, if k is the actual, if k is num's length times nums1 length times nums2 length, that does seem like it might be a big number. I mean, this thing's like, the loop that I'm thinking of is going one at a time, trying to figure out what the best next one is. And the next best one, when the loop could possibly be 5 times 10 to the fourth. 5 times 10 to the fourth is going to be, or 5 times 10 to the fourth squared is 25 times 10 to the eighth, which is a pretty big number. But then again, I don't necessarily know how you shortcut that. Like go to the nth one. All right, whatever. Let's see how bad this is. Let's say I have a heap, and the heap is going to be the boundary heap. Boundary, and by boundary I'm thinking of heap of smallest products in consideration, and I'll have the small column low row, and this is going to be for the, actually let's go ahead and say nums1 is my rows headers. So I'll say the number of rows is equal to length of nums1. I generally think of rows using, actually, let's say nums1, the rows is nums2, length of nums2. This might be confusing at some point, because it's kind of arbitrary, but I generally label the first array as the column array. So for every column, I want to keep the track of what the lowest row that's being paired with it is. So it's going to be low row, low row for column. It's going to be 0 column, row 0 for every column. So times the columns. And then the low column for row. That looks so bad. That's not readable. I'll just say low row. Low column is going to be 0 times the number of rows. This is tracks lowest paired row for each column, and tracks lowest pair column for each row. And I think in sum that should be enough to keep track of where the boundary is, or where the boundary might have gone to. For each, let's do a while loop here. For loop or while loop? For loop. For each, for each k count, for each k count, for each k range k, that's going to be too confusing. Current, okay, sure, current range k, So each time I do a loop, I'm going to try to figure out what the thing that I should be considering is. So the boundary should actually start with not an empty array, but with the first product. So do I want to make this a tuple? Yeah, I want to make this a tuple. I think it should be, it should have a tuple of product and tuple of product, row and column. So this is going to be boundary is heap of tuples, smallest tuples in consideration where each tuple is product of. So this should be, the initial thing is nums1 of 0 times nums1, nums2 of 0, comma 0, 0. Okay. And then I'll say heap q dot heap pop the current thing, which is from the boundary, and that should give me a product, a row and column. So I get the smallest thing, and then I need to push onto the heap the next things in consideration based on that, assuming that it is better on the boundary. So for a given row, if the next, let me think. So for a given row, if the low column for that row is, so I have 0, 0, I'm going to check 0, 1, and 1, 0, right? Or if I have 1, 0, row 1, column 0, I check for 2, 0, or 1, 1. And 2, 0 is fine because the low row, or the low column for row 2, for row 3. Okay, so if the low column for the next row, which is row plus 1, is at least this column, is equal to this column, is equal to this column, then heap push onto the boundary, heap the tuple that is, let's say, product, or new product is going to be nums, so rows plus 1, rows is nums2, so nums2 at row plus 1 times nums1 at column, and then this is new product, row plus 1 column. And then I want, do I need to change the value? So if I take 6 and consider 8, then the low row in this column is 1 more. The low row in column, the low row in this column is equal to row plus 1. This is right. If the low column, so 6, the low column in this row is equal to the current column. Yeah. Oh my god, this logic. And these this is so easily confusable. Oh my god. Okay, so 6 goes to 8. Well, that's really not the thing. So when 8 goes to 30, but not to 20. So 8 is 1, 0. 8 can go to 30 because the low column for that row, is column 0. Low column for that row is column 0. And now when I make that move, then the low row for this column is now that row. Alright, I think this is fine. If now moving it the other way around, can 8 go to 20? So if the low row for column plus 1, so for the column the low column for the row plus 1, the low row for the column plus 1. So for column plus 1, which is this column, the lowest row is row 0. So it's equal to the current row. But it's not, so it's not going to do this. But if it is, then it's going to be product nums 2 at row times nums 1 at column plus 1 eq.ePush boundary tuple new product row column plus 1, and then based on the other logic, making the complement of that, low column of the row is equal to column plus 1. If I want to try to think through that. So if I could go 8 to 20, then I would make the low column, yeah, I think that's right. Okay, so let's say 8, 6, 8, 15, 20, 6, 8, 15. Okay, so when 15 is removed, it does both. So does that logic apply? So when 15 is the product and row is 1, column is 0, no, product is 15, row is 0, column is 1. The low column of row plus 1, so the low column of row 1 is currently 0. So therefore you increase the low row. All right, let's just whatever. Print out heat Q each time and return 0. Out of range. Oh boy, oh boy. The low row. Is this giving me the correct sizing? The number of rows is the length of the low row should be based on the number of columns. I think that's, I mean, if I consider this as my, these as my columns, these as my rows, these as my columns, my rows, then what? I think it's going to be for every column where the number of columns is 4. Huh. How is this going out of bounds? Oh, yeah, okay. I never actually checked whether or not I'm at the cap row. So if I can't go, if the row is less than, if the row not equal to rows minus 1, yeah, columns not equal to columns minus 1. I think the sizing is correct. It just can't actually go adjacent for still out of bounds. Index out of range on this line. How? What? Oh, boy, pretty out of the wrong thing. It's empty. Interesting. Interesting. Can I Let me just do the one test case. Test case 1. Wrong answer. Okay. 0, 0. Holy shit. Okay, yeah. That's just the thing. Actually, yeah, that's just the thing. Okay, so on the first pass, it gives 8 and 15. That's correct. And then on the second pass, it does 15. Should this be k minus 1 for the number of loops? It should be k minus 1. And in theory, it's going to return the top of the heap. So the boundary at 0, and then the product of that. Okay. Let's go ahead and reset test cases. Let's just look at test case 2. Okay. Actually, I'm going to go ahead and just do my test case that I was considering. So 2, 5, 8, and then 3, 4, 15. And let's go and get 1, 2, 3, 4, 5. Let's get the 24, ideally. Okay, so 8, 15, sure. And then 15, 30, that's right. So it gets the 15 off, and then it doesn't add the 20 as it should. It doesn't get the 20. So it gets 24 but not 20. So that means that from row 0, column 1, row 0, column 1, at that point, what is the state of the low row and row column at that point? So I only increment this when I actually push in that direction, I want to say. So let's go row, column. Okay. So 1, 1, and then when I do the 15, when I do the 8, so when I do the 0, 0, or when I do the 6, it becomes 1, 1 as the boundary for the lows. And then when I do the 8, 8 pushes this thing to become 2. 8 pushes this thing to become 2. Does the 8 still, the 8 still should push this thing to become 1. even if it doesn't add it to the queue. Yeah. The low roll, maybe these things are automatically done. The low roll, God, this is kind of a hard thing to pronounce. The low row for this column is pushed to the next row. Yeah, I think maybe this is just automatically always done. Oh, okay. Let's go with test case. So there's 9 here, so let's go 8. Okay, that worked. All right, let's go with the other test cases. Okay, this one didn't work. -2, -2. Case 3, so the third smallest. So the smallest is going to be -6. And then the next smallest should be negative. Oh my lord. It's actually not. It's not adjacent. Oh shucks. Oh boy. That's not good at all. The smallest products are -10, -8, -6. Oh no. They're not all positives, or their signs are gonna fuck this up. Oh boy, oh boy, oh boy. So how would the signs work here? So a negative and a positive is always going to be smaller than any combination of negative, negative, or positive, positive, or 0. Can I still work with that though? So the 3 smallest products. So we're going 0, 4, 0, 3, or 2. So treating these as positives. So some combination of those positives and these negatives is always going to be the smallest compared to other combinations, or some combination of these negatives and these positives. Is there a simple way of incorporating that? So if you just do out your signs, could you, if you just looked at it without their signs, is it even possible? Third smallest. So the smallest is going to be the biggest The smallest is going to be combinations of positive and negative, or whatever that is, positives and negatives. And then it's combination, and then it's some number of zeros, and then combinations where it's either negative and negative or positive and positive. Ooh, mamma mia. What if I just assumed that these are both positives, they're all positives, and then, or make a sub function where they're just positives. No, fuck. Oh, that's so close to being doable. I was thinking maybe doing this, like, sectioning off into like 4 possibilities, or maybe 9 possibilities, but like creating subarrays where you had just the positive numbers and just the negative numbers, and you're finding the kth value from there. But I don't think that works. I don't think that works. Does it not work? So what would that array look like? Some number you have to treat. Could you just combine all the negatives into one bucket? No, I don't think you can. Combine all the negatives into one array and all the positives into another array, and then find the kth element of that as one thing. I think you're fucked when it's actually negatives and negatives versus positive versus positive and positives, because it might be workable for the negatives to be combined to in a single array and the positives to be combined to another single array, and then finding the kth element of that, or skipping it over completely and removing that number of products from K. But then when you have the negatives combined, when you have the multiplication of negatives and negatives and positives, that's where it doesn't make sense to combine them, because then you're just, what are you combining? They're from the same set of things, like negatives multiplying negatives, positives multiplying positives. They would have to compare with each other somehow. All the combinations there. Negatives multiplying negatives. If you have negative multiplying a negative, then you have this kind of a 4 products here, like 1, 2, 3, 6, and then you have also the positive multiplying with the positives, and you have 6 products there, like 2, 4, 4, 2, 4, 4, 5, 2, 4, 4, 5, 8, 10. And the 2, 4, 4, 5, 8, 10 needs to combine with the 1, 1, 2, 3, or the 1, 1, what was the other one? 3, 1 times 1, 2, it's 1, 2, 3, 6. So those things intermix. Those things intermix. 1, 2, 3, 6. 2, 4, 4, 5, 8, 10. Can you make an algorithm that intermixes them? That tries to weave through comparing the smallest of one product list versus another product list? Maybe. So instead of just looking at the lowest of the heap, so you have two boundaries that you're dealing with at that point, and you're taking the lowest of each boundary to determine what to do next. But the boundaries are separated. Oh boy, oh boy. Yeah. That's kind of brutal. It's kind of brutal. Okay, so you start by counting the number of negatives in each, and then, so what am I thinking? So I'm thinking of negatives. Let's say P1 is the set of positives from nums1 n1. Actually, the positive one is set of positive from nums1. Neg1 is set of negatives. And then negatives 1, and then similarly pos2 and neg2 are positive and negatives from nums2. So you do the, so order overall will be some products, set of stuff that is positive 1 times negative 2 union with positive from set 2 times the negative from set 1, and then it's going to be less than some number of zeros, it's less than the positive 1 times positive 2 union with the negative 1 times negative 2. Right, I think this is correct. And then these you can, this thing you can make we'll call this A is less than 0 is less than B to those things. A can be found by combining negatives, positive pos 1 plus pos 2 into a set. Any combination of positive and negative. I think you can make them into a single set. No, that's not right. So if you make this positive one into a single set, then you're dealing with some, you could be possibly dealing with a positive one number times a negative 1 number. So you're multiplying things in the same set. Okay, so I think maybe each of these things I need to have a way to iterate over 2 boundaries. Yeah, so need to pair low of 2 boundaries at any given time. So like this is the low of 1 boundary, where the boundary is based on something that is like all positives or all negatives or one side of the coin. I see. Okay. Interesting. I think I need a subfunction for this. Okay. So let's say I have pair 2 boundaries. So I'm going to make this into this is mostly comparing 1 boundary right here. And I want to find the kth element of this boundary. And there's going to be nums1, nums2. I'm just going to enable this as rows and columns. Rows. No, never mind. So it's going to be nums1, let's say for the first table, I would prefer having nums1 and nums2, I guess. Nums1, nums2, nums3, and nums4. Kth element of that, returning an integer. Alright, since I'm doing this in Python 3, I might as well actually use some proper dealios. Type declarations. I guess these would be. I guess these aren't type declarations, these are something. I guess these are type declarations. Well, I need self here. Probably not. It is a subfunction. Non-instanced, I don't think. Alright, so this is boundary 1. Do I want to say boundary 1 or boundary? Boundary 1. So this is boundary 1. And then I'm going to do the same thing for boundary 2 pretty much. Boundary 2 is equal to a heap for nums 3 of 0 times nums 4 of 0, 0, 0. And then the rows and columns would be rows 1, rows 2 is the length of rows 4, columns 2 is the length of columns 3, low row times columns 1 here times the number of columns. Row call 2 is the number of rows. Okay. And then here, this is row 1, column 1 from product 1. And product 2 is from row 2, column 2. EQ of heap push. See, this could be empty at this point. Heap pop of boundary 2. Yeah, could be empty. Oh. Oh. Alright, so maybe I can say if there is a boundary 1q at this point, then do this. And maybe I initially set boundary 1. Actually, product 1, product 2. I'll initially set these to be infinite, I guess. Infinite. Okay. You could also use. So they're going to be really large initially. If they're not, if there's nothing in the, if there's nothing in the queue. Oh, the heap. I did call this a heap, right? Yeah, boundaries heap. So, and then this is all conditional on product 1 being smaller. If product 1 is smaller than less than product 2, then pull from the product from the boundary one stuff. And that would be if the row 1 is less than rows 1 minus 1, and the row column 1 is less than row 1 plus 1. Column 1, nums 2, row 1, 2, new part row 1 plus 1, column 1. If the column 1 is less not equal to columns 1 minus 1. I should label this like A and B or something rather than 1. It's kind of hard to read. This is how I describe this. Hard for someone else to be able to read later on today. Do a code inspection. Row column 1, row 1, row 1 plus 1, row 1, column 1. Okay. Else this whole stuff, but pulling from the other. So doing the same process, changing it to 2s. 2, 2, 2. Nums, this should be nums 4. 2, nums 3. And then 2. This is row 2 column. Row 2 column 2, yeah. So 2 columns 2. Now this is low column, low row 2, low row 1. Yeah, I need to pay attention. This could be easily where a lot of bugs actually occur within no bugs. Okay. 2, 2, local 2, row 2, column 2, row 1, column 2, 2. Let's double check. If the smaller product is in the first boundary, then check if the row is not the last row, and then check if the column that for the next row is equal to the column here. And then push onto the heap. And then do the same thing for the columns. And then find a new product. Yeah, this is, oh boy, that would have been a bad mistake. That would have been god awful to try to figure out. Columns, row, column 1, 2, 2, 2, new product row, row 1, row column 1. Okay, that looks fine. That looks fine. That looks fine. Nums, yeah. And then, yeah, Yes, and yeah, okay. So it gets the boundary, and so it has the k lowest boundaries pulled from those two. So now I can say pull the first if there is anything. So if no, if not boundary 1, pull the first from boundary 2. Else if not boundary 2, pull the first from boundary 1. Or any return from the sub method. Boundary 1. Else return the smaller of the 2. Yeah. Boundary 1, first element. Boundary 2, first element. First product. Okay. Now to call this subroutine correctly. So I have defined 2 boundaries. Defined. So I need to break it up into positives and negatives. So I think I need to find the indices of 0 for each. Or I found where the first positive is. Do I need to... I could maybe divide into where negatives and then zeros and positives. Negatives versus zeros and positives. Because when I do the flip, I flip the negatives into positives and call the subroutine. Okay, so I should probably use a search bisect. Python bisect. How to use bisect again? Bisect left is the normal thing. Yeah, function returns the insertion point of x in a 2. All right. Let's say split index. Split 1 equals bisect left of the array, the value, nums 1 0, yeah, and then split 2 equals bisect left of nums 2 0. Determine where 0 is in 0, where value 0 is in each array to make subarrays of positives and negatives. So split 1 is that. So I say positive 1 is going to be the nums 1 the nums1 at from this. I guess I should probably check if it's non-zero. So if it's not 0, then what happens? Or if it is 0 negative, then what happens? If it's 0 negatives, yeah, it's whatever. I have an empty array. Pos 1 is going to be, it's going to be the subarray splicing nums1 from the start to split 1, and neg1 is going to be nums1. No, that's incorrect. These are negatives. Negative ones are back, positive ones are nums1 and split 1 on. And then similarly, neg2 is nums2 up to split 2. Plus 2 is nums2 after split 2. And I guess I can probably do a count. No, the count is just a split number. Count is just a split number. So if k is less than the number of -1 times +2 plus +2 times -1. So let's say there's 4. Let's say the number's 4 things that are total. Then k can be 0, 1, 2, 3, or 4. So I think this should be +1 here. So if k is less than 5, then you're going to pull it from this. So a is within the products found from k is a negative product found in first k values from some combination of positive times negative in appropriate sets. So in that case, we're going to do we need to make these into positives strictly. So let's say array 1 is negative value for every value in -1. And oh boy. Array 2 equals negative value for every value in -2. Then return and compare two boundaries. I wonder if order matters here. I don't know that it does, to be honest. I don't think it does. So anything, compare the two boundaries from nums1 and nums2 are things I need to multiply. So -1, basically. -1 with +2 and then -2, +1. Okay. Okay. Is it K? I think it is. Else, it's going to be I still need convert. Do I need convert? This other one's unusual because I'm multiplying negatives and negatives anyways. But the bigger the negative, I might as well convert it. Actually, this is always going to be done, isn't it? So K is going to be reduced here. Return, compare two boundaries of array 1. So -1 with -2. And then +1, +2. And K is reduced by the, actually K minus equals the number of things that are contributing. Oh, these are the, oh shucks, these are actually the counts, right? They're supposed to be the counts. I actually meant, no, these are supposed to be the splits. So count, let's say C for count. Count of, actually count of -1 is split 1. And then count of +1 is n. I go back to hiding. So I think I need to know the number of each. So I'll say values 1 is the length of items 1. Maybe just count 1. Yeah. God damn it. Count 1 is the length of nums 1. And count 2 is the length of nums 2. And then I can say here count of the -1. Count of -1 and count of +1. Split 1 and then nums 1 minus split 1. Count of +1 or -2. And count of +2 is maybe split 2. And nums 2 minus split 2. And then the K is less than. I can just say product count of the product that is negative is this jazz. Count of the -1 times the count of the +2 plus count of the negative. This is actually the same. God, that's horrible. Count of the -2 times count positive 1. Yeah. So this is counting the product of the negative plus 1. Otherwise, k is subtracted by that. Count of the product of the negatives. And then find the kth value of that within these two boundaries. Okay. Is my tabbing wrong? Nums1 and nums2. Nums1 split will be count 1, count 2. Index out of range. Oh boy, oh boy, oh. It's because it's empty, isn't it? What happens if it's empty? You really can't compare two boundaries if there is no boundary to be had here. I see. I think maybe I can say if nums1 and nums2, then do this. Otherwise, my boundary 1 or my boundary 1 and my boundary 2 is initially empty arrays. And similarly here, if nums3 and nums4. Nums3 and nums4 is not defined. Ah, good old plural versus not plural. Ambiguity. That's probably not the last time I screwed that up pretty big, huh? Nums4, nums4, nums3. Not the last time, but hopefully the last time. Yeah, I did mean nums3 on line that. 51, 41. Yes, I did mean boundary. I mean boundary 1 here. Oh boy, is boundary by itself defined? Oh my god. Line 7. Good old nums versus num. Whoops. Okay, excellent. Still not working, but running. I can quickly see that this should be. This is not going to return the correct signage. I think I need to make this, by the way, negative 1 times this, just to be extra explicit about that product being negative. Okay, so let's go ahead and, so k is 3 here, so it's going to be negative. So I'm saying here print Let's go ahead and just print out the count product that is negative, just to verify the countage is correct. So that is not correct. The count of the stuff that's negative should be 4. So what to do here? Count 1. Count of the number of negative. Count of the number that's negative should mean, I think that's actually right. Of the number that's negative. Okay, I guess I just need to be more clear here. Count -1, count +1, count -2, count +2. Okay, so let's see if these 4 numbers are right. So there's 2 numbers in the first array that's negative, 3 in the second, or 2 in the first that's positive, and 2. Oh yeah, actually the number of negatives is actually right. So 2 times 3 is 6. And then actually, let's see. So here 2 times 3 is 6. So it is 12 negatives. Okay, sure. Okay, let's go back to the compare 2 boundaries, and I'll just, each time it does the loop, I'll just print out what's in the loop. So print the boundary 1 and boundary 2. Okay, so it's looking for, oh, that's not good. That is not good at all. One of the boundaries is strictly empty. So it didn't actually, let's go ahead and start by doing this. But initially not empty, okay. It's initially 4 and 0. No, it's not good at all either. This should initially be like maybe 10 and 6. Interesting. Let's go ahead and print out what the call print nums 2, nums 3, and nums 4. Whoops. Nums, not num. Okay, that's actually right. It's 2, 1 with 2, 4, 5, and then 3, 1 with 0, 1, 2. But what I'm really looking for is the maximum here. 2 times 5 is 10. Yeah, what I really care about is doing the maximum. So should I be reversing it? Well, it's a couple issues. One is the heap is always going to do the minimum. So the heap is always going to do the minimum. So maybe I should be keeping them as positive and negative. Because when I do the product, it's always going to be a negative product, or it's generally going to be a negative product. So that works fine. And would that work if I was to be the other way? Or do negatives and negatives? 2, 1. So we should really be doing 2, 1, and 5, 4, 2 in order to do. No, but I still think of the minimum. The minimum. So maybe it should be just keeping it as negatives and positives without changing the signs. Because then it'd be. No, it should be keeping these as negatives, reversing this, reversing the positives. So then I can multiply -2 times 5 and get -10 in the queue. Keeping the negatives, reversing the positives. Keeping the negatives, reversing the positives. So keeping the negatives, -1, the reverse of the positive, and then keeping the negatives and reversing the positives. So it does go correctly -10 and -6. Do I need to diagram this? So this is going to be -2, -1, 5, 4, 2. So it's -10, -5, 8, -4, -4, -2. The other one is -3, -1, 2, 1, 0, -6, -2, -3, -1, 0, 0. So it looks at -10, takes that away, comes, should have -5, -8. Somehow I took the -6 instead. That's not good. What's going on? If the product 1 is smaller than product 2, product 1 is from boundary 1. But then this should be -10 to -6 now. Comparing -10 to -6. So it's removing the -10. Because I'm fucking popping it. I'm so stupid. Okay. I should not be popping. I'm just previewing it because I don't necessarily know that I popped it. So I say infinite. If there is a boundary, then product 1 is just the top of it. No, just the top of it. Boundary 1, 0, 0. And then if it is, then I pop. Else, otherwise, if there is a boundary tree, then product 1, 2 is equal to boundary 2, 0, 0. And then there you go. Pop that. Okay. Okay, well, at least the other one didn't get popped immediately. But then the still's not right. Oh, it's just not right because the wrong signage on the output. The signage is now correct. Okay, now this is probably not going to work if it's in the higher regions. So I need to check the higher regions again. Test case, so there's 12 small ones, so let's go with like 15 out of the 25. It's probably not. What? 0, whatever. So let's go with 24 out of 25. And it does work. Well, that was definitely a bunch of wrong turns getting a right answer. Even if my logic is probably faulty in creating it. Array 1. Let's see. So 24. You want to 2, 1, 3, 1. Array 1, 2, 1, 3, 1. So these are now positives. So the lowest there is 6 versus 0. That really should be like 1 versus 0 now. How's this? How is this even working close to being right? It should be 1 versus 0. 6 times 3 is 2 times -2 times -3 is 6. But you should be comparing. Okay, this is just no. There's no way this is right. Let's say this is like 13. There's no way. What? So it's not that you're looking for a negative. It's looking for the smallest positive. So it's going to be 0. Hmm. 14. This just cannot be working correctly. No. 14, 15, 16. There's going to be a bunch of zeros. There's just no way. 17. Let's do 20. I refuse to believe my code is correct. Okay, there we go. Yeah, this should definitely be reversed. So, or can I keep it in negative form and reverse the negative form? I think I can just reverse the negative form. So -1 reversed and -2 reversed. So that would be, this is like -1, -2, -1, -3. I think that would actually work. Yeah, I don't need to make these other arrays. I think I got rid of all references to array 1, array 2. Okay. Oh boy, oh boy, oh boy. Where's that last printout? Okay. Let's see if this thing does okay. Too slow still? Yeah, it could be too slow. Oh boy. So there's a lot of duplicates here. A whole lot of duplicates, I guess. That I could probably optimize for. Hmm. Do. 86 out of 112. So let's use this test case. Let's go ahead and just put a count. Counter is the counter of nums1. Counter equals the counter of nums2. Counter 2 is the book of nums2. Just to see what the distribution and how. Oh shit, this got time out. Just to see how many duplicates I have to deal with here. Yeah, it takes 2.7 seconds just to do this one test case. I'm assuming it's because there's a lot of duplication. So there isn't duplication. So I mean, there's maybe 7, factor of 7 for a fair number of them. So the factor of duplication would be the same factor of reduction in speed. If I were to handle it kind of constantly. How would I handle duplications? Uh, hmm. I have a, maybe I have a counter dictionary or counts dictionary, and I go through unique values of each array, and when I increase k, I'm technically increasing by the count of that value in that array rather than just by one, or increasing by the count of the first value in the first array times the count of the second value in the second array, rather than just by one. I guess that might work. I guess that's probably the most straightforward way. So say frequency 1 is equal to nums1, frequency 2 is the frequency of numbers in nums2. At least at this point I haven't actually changed the frequency because I just reordered them. So I could look into this frequency as long as the thing is referring to the right, as long as it's referring to the right it's looking at the right areas for the frequency. So nums1 is from, should be using frequency 1 stuff. And nums2, so stuff that's originally using nums1 should use frequency 1. And how do I make that consistent? So nums1 becomes -1 and +1. Nums1 becomes -1 and +1. -1 and +1. So the first list should be from, nums1, and the second list should be from nums2. First list should be from this is the wrong order right here. First thing should be from frequency 1. Things from frequency 1, frequency 2, frequency 1, frequency 2. Okay. Is that right? Right. So what is the issue I'm thinking of right now? So frequency 1, frequency 2, frequency 1, frequency 2. I need to still convert these lists. God damn it. I need to, so I split up, I bisect it. I think I need a bisect sort. bisect then you convert these arrays into removing the duplicates. Yeah, I need to remove the duplicates. So even after I figure out where the split is, I guess I don't even care about what the split is. No, I do care about where the split is. It's probably the fastest way of determining the counts. Is it? I think I need to have a loop that actually creates the positive and negative stuff rather than splicing it because I want to remove the duplicates. Okay. So this is the old way. So I just need to create subarrays of positive and negative, or negative and positive, or positive or non-negatives from each without duplicates. So I'm going to say index is equal to 0 while index is less than n. Now how to do this without having an extra statement? I think I can do something like nums1 dot append infinity and nums2 dot append infinity, and say -1. Let's say iterating over while nums1 at this index is less than 0. Then -1 append nums1 at this index plus 1. Same deal for -2. Index 0 while nums2 at this index is less than 0. -2 dot append nums2 at this index plus equals 1. Okay. And then before I reset here, I can say -2, +2, +1, +2. And oh shit, I want to remove duplicates, don't I? remove duplicates. Append it if it's not the same. So I could start off with having something in the -1. Man, I'm making this too hard on myself. If there is an element in -1 and that last element does not equal the current element. Okay. It's going to be a little slower with the if statement, but whatever. And then here, while +1 / index is less than infinity, why am I using infinity if I have an index anyways? I guess I don't have a double check for the index being out of bounds. Or whatever. If +2 is, if +1 is there and the last element +1 doesn't equal this thing, then +1 dot append this value. Okay, so keeping the same index through this whole process. Go through and find the negative numbers, add it to -1, and go through and find the positive numbers, add it to -1. The last number is guaranteed to be infinity because of this. And then reset that index back to 0, do the same thing for -2 and +2. And let's see if this index is less than infinity if -2 and -2 are not equal to nums2 of this index. -2 dot append nums2 index. Okay, and I do need to say nums1 has infinity at the end. Okay, mainly, so the reason why I did this thing is otherwise you would need to check while index is less than n each time, because it could be going out of bounds, but I know that it can't go out of bounds due to this thing always ending at infinity. So it removes one if statement from the while loop at the cost of appending an infinity. So I think this is fine to remove duplicates. Let's go ahead and just verify. Print out my -1 +1 -2 +2. Oh no. Name counter is not defined. Frequency 1, frequency 2. get rid of that. +1 at index. Oh, jeez, it's going out of bounds already. While, oh, whoops, this should be nums1. Okay, well, that doesn't look right. That does not look right at all. Looks like it's just giving me blanks. Well, this one's not blank, huh? Oh, it looks like it may be getting negatives correctly, but not positives. Nums1 is less than infinity. So it appends increments. Oh, this should be if it's empty, if it's empty. If it's empty, or if it's not empty and it's different. If it's empty or if it's different. There's different here. Two, or the last thing in -2 does not equal this thing. Okay, so looks X. This is correct. This is not correct. The negative should just be 3, 4. Or the negative should be empty and the positive should be 3, 4. Index is back to 0. Nums2 at 0 is less than 0. If so, it should be not doing anything there. And then if it's less than infinity. It should be resetting back to 0. Yes, it's not doing the negatives for nums2 correctly. Because I'm adding it to the wrong one. Let me see. +2 and okay. So positives and negatives are correct. And then this one is without duplicates. Am I printing out the counter? Oh shoot. Alright, so okay, so this is strictly non-duplicates. So it does look like that's correct. Oh, okay. So wait, I just delete now. Okay, delete that. And then I don't want to return here quite yet. I do need to find the number of them. The number of them is fine. I don't need to actually create this anymore. And then I do need to still keep track of the counts like this. I could also keep track of the counts by just doing counter within the for loop, but this is fine. And then that's still fine. And then here, this is still fine actually. Yeah, this is still fine. Okay, so now it's modifying the subroutine or subfunction. So the boundary, all that's okay. This is not okay. Well, is it not? Yeah, it's not okay. So currently it's at 0. And then while current is less than k minus 1. So k is 1, then I don't want to do that at all. Yeah. Actually, let's go ahead and just comment that out. And then when I do a removal, it should increment the current by the count, the number of times this product occurs. So because this is currently doing something from the first boundary, how's it using nums1? Nums1 and nums2, and here should be nums1 is from frequency 1 and nums2 is from frequency 2. Nums1 is from frequency 1. So the columns, so should I be this nums3? Okay, so anything that says, so it should be frequency 1 of the value that is from nums1. Value from nums1 is I believe the row 1. I think that's how I ordered the. So 0 row and column, right? Yeah, so the row is from frequency 1. So frequency 1 of the value nums, oh boy. So nums1 at frequency of nums1 at the row No, I index nums1 at column 1, so I'm going to go with that. Times frequency 2 from nums2 at row 1. Yeah, I'll go with what I used in these. Current plus equals frequency 1 nums3 columns 2 times frequency 2 nums4 at row 2. And technically here, if current is greater than k, I think I need to return this value immediately. Because I could be going from, let's say I'm finding a 10th value, I could be going from current is like 5 to 15. I don't want to get the 16th value, I want to get this value. So if current is greater than k minus 1, it's fine if it's, let's see, if I want to find the first one, normally incremented by 1. So I think this should be greater than k. It's fine if it stops and the next loop once greater than k minus 1. It's not fine if the current loop stops when it's greater than k. Turn the current product. I guess I could do that outside of the if statements. So still getting this one wrong, but it's going faster when it gets wrong at least. Okay, let's go ahead and try one of these things with the duplicates. So let's say 2, 2, and then 3, 4, 4, 4, 5. Let's do test case 10. So probably this is like, it should be 8 if it doesn't crash at all. Infinity is not a valid return type. That is correct. Really? Given me infinity. All right, so let's go ahead and where is this going to crash? I mean, it's probably doing this thing right here. Probably fine up to that point. Okay, so let's go ahead and print out the numbers again. Finding k in the positives. Ooh, that's not good. 3, 4, 4. That should be That's not removing the duplicates there correctly. Yeah, I'm an idiot. If not positive 2 and not positive 2, a little too brain dead on the copy paste job there. Okay, so again, it's going infinite. 2, 5, 3, 4, 5. Okay. So how is it even returning infinite here? 2, 5, 3, 4, 5. How is it turning infinite here? So it's going in the subroutine. Initial products are infinite. And then it's set to set to the boundary that's actually there. So it's, if I guess both things are empty, so both things, so infinite versus infinite, so they both have to be empty. Right. So it's starting off with 600 versus 600 versus nothing. And then the next time it goes up to 8 or 15 to 2 times 4 versus 3 times 5. And it went up from 0 to 4 because there should have been 4 2s and 1 3, so that should have been 4 numbers. And then what? And then it didn't do anything. So then it just returned infinity. If the current is bigger than K, well, shucks, I can't do this. If current is bigger than K here, return the product one here. I'm so, I have lost a lot of steam here. If it's this one, return product 2. My brain is definitely not fully functioning. Output limit exceeded. Fair enough, fair enough. Yeah, this is still too slow, I think. Like, this is taking 1 second, pretty much. Let's take that timeout. Finding K in the positives. Probably get rid of that if statement. Yeah, still too slow. Wow, not even correct to the same extent that it was before. Let's go ahead and try this out. Finding k in the or k in the negatives. So it's going to be 2 times 7 is 14. 6 times 4 is 24. 14, 24 is 38. So it's, yeah, it's finding the negatives. Okay. So we don't want to map out all 38. 36 in some way. How is it 36? 2, 1, 2, 3, 4, 5, 6. Okay, let's count it. So 2 times 6 is 12. 12 plus 24 is 36. Is it my counter? Is it my counter? I mean, the counter worked the last time. Probably should work this time. Still dealing with the negatives. Still dealing with this portion too, because it's never really. Is it? No, I guess not. Alright, fine. Let's go ahead and just provide the boundaries here. Remove the big test case. Really just concerned with this test case right now. Alright, so negative 90 versus negative 100. So it's going from negative 9. So it's removing the negative 100. And there should be 2 copies, so it's going from 0 to. And here's negative 90, negative 90, negative 80. And so it's probably taking this negative 90. No, it's just taking this negative 90. And this negative 90 is going to be negative 10 times 9, so that's 2. So it goes 2 to 4. Ooh, what is going on? There shouldn't be. Oh, okay, negative 8. Yeah, that's fine. So it's negative 8 versus this 10. Or. Wait, what? Negative 90 from 0 to 1. Or this is 0, this is 1. And then it could keep this and go to this, or it could keep this and go to this. Sounds good. Oh, no. It's this 8 and this -10, or this 10 and this -8. I see. And then, but it does remove the -90, so it goes to 4. And then moves this -90 and goes up by 1. I'm looking for K is 29. So then it moves this -80, and it should go up by 4. This is like -10. There's 2 -10s, 2 +8s. And then it moves this -80, and that should go up by 2 because there's 2 -8s and 1 +10. Then moves to the -72 from the -9 and 8. This goes up by 1. Goes up by 2. Tell me why. Why does it go up by 2? -72. So remove this -80 here. Oh, no, remove this -72 in the second array. -2 in the second array is 8 and -2 -8s and 1 9, so there's 2. 11. And then there's another way of getting that. It was from should move this -72, okay. And then move this -72. Well, no, what's going on here? Move this -80, went up to 11. Move this -72, went up to 13. Or move this -2, went up to 14. Then remove the -64, and it went up to 18. -64 is 8 times -8. Okay. And then it moved the -60 and went to 20, up by 2. 6 times -10. And then it removed the -54. And there's 2 ways of doing that, -9 plus 6. And then it removed the -48. Ooh, that does not look great. No, remove the -54. Yeah, so I just did that. Yeah. Move the -60, went up by 2. Move the -54, went up by 2. Move the -48, went up by 2. -48, 6 and 98. And then remove the -48. Man, this looks pretty solid. 29. Current's greater than K. If it doesn't hit that if statement, then it should go here and break if current is K minus 1. It breaks when current is K minus 1. Breaks when K minus 1. So I think it actually should be if current is greater than K minus 1. All that for possibly just that. Oh my god. Yeah. Edge cases. They're pretty sharp at times. Sharp edge. Whoops. Let me comment this out. And I need to comment out blueprints. Okay. Please. I'm willing to accept a non-optimal solution to pass the time trials. It's not passing time trials. Yep. Oh my god. Oh my lord. The time trials, the time trials. Okay, so I think, okay, let's see how long it takes. I think maybe my solution would work on this thing, but it takes too long in the more complete set of test cases. Or it takes too long even in this case. Really? This individual case is just too long. Alright, so I think that means that my solution is just not good enough. Not good enough. Like the speed is just too slow. Alright, I think I need to actually stop. It's been close to 3 hours, I guess. Alright, I'll try.